So I've got this cool thing to show you. It's a custom Bahtinov mask to help me find perfect focus. It has DSD for deep sky detail on it. You can do it with free software and a 3D printer. I'll show you how. Welcome to Deep Sky Detail. So this Bahtinov mask is pretty cool, but there are some problems. The spikes are in the wrong direction, and it's a bit hard to pull out through the dew shield because there is nothing to hold on to. So I'm going to make another one and show you how to do it. So the steps are this. First, make a PNG file of the Bahtinov mask design. Second, convert the PNG file to an SVG file. Third, upload the SVG file to FreeCAD and extrude it to create the 3D model. Fourth, open it up in something like Cura and make the dimensions fit your scope. An optional step is to use a free piece of software called SpheroFront to check if your design actually works before you print it. Let's get into it. So I have this template of a Bahtinov mask here in PNG format. You can screenshot this and import it into GIMP or Photoshop if you want. I'll also leave a link to where I got this one if you want to download it. If you don't want to add your initials or customize it, you can actually skip this step and go to this website and make an SVG file directly. Before we get started designing, we should probably go over a bit of theory. The white in this image is where light will go through the mask. The black will be the solid material. The solid part creates diffraction spikes in the middle of your camera's sensor when a star is in focus. The diffraction spikes are perpendicular to the lines in this image. So this set of lines will create a spike like this. This set of lines will create a line something like this, and these vertical lines will create a horizontal diffraction spike. We want to avoid curves as much as possible because curves will create a blurry mess that won't be helpful when focusing our telescope. So as much as possible, I'm going to try to follow these lines. What I need to do first is create a circular edge for the mask. I'll design the mask in a new layer. I'll also invert the colors. I am pretty sure it's important for the SVG file later on if black and white are reversed. I'll select the ellipse tool and make a circle. Then I'll hold down the control button as I make another circle. This will subtract the selection of the second circle from the first circle. I can then fill in a selection with white to make an outer ring. Also, if you have a secondary mirror, you'll also want to create an inner ring that has nothing inside of it. Make sure to get the proportions right though. Now let's say I want to add letters or initials. In my opinion, the best way to do it is to try to make the lines and letters parallel with one of the three sets of lines on the mask. Also, you want to make sure that the letters don't have very many curves in them. Here's the design of the first mask. All the letter outlines are parallel with one of these sets of lines. However, the mask will work better if this set of lines is horizontal and not vertical. So I'm going to erase them and make them horizontal. Now, there's an optional step that you can also do. We can check how the mask will work by putting it into SpheroFront. The link is in the description. All we have to do is upload the PNG file and select Allow Recalculation. It will then show the diffraction spikes when in focus. You can turn up the exposure to simulate a bright star. The focal length and defocus parameters are in meters, from what I understand. So to check what it looks like defocused, change the defocus parameter to something like 0.002. Nice. Will this be the best Bahtinov mask? No, but it should get the job done, and having initials on it seems pretty cool to me. Next, what we need to do is go to this website here and convert the PNG file to an SVG file. Just choose the file and press Start. You really don't have to worry about any of the settings below. All of the dimensions can be changed in Cura later on. Download the SVG file and open it up in FreeCAD. So to open it up in FreeCAD, you want to change the workbench to draft and then go to File, Import. It will ask you how you want to import it and select SVG as geometry. It will then say that it doesn't know how to create the dimensions for it. We didn't specify this earlier, but it's fine. Just click OK. Now when I import mine, there is this outside square. I don't need that. Just click on it and select Delete. With Draft as our workbench, we want to select all the paths by clicking the top path, holding down Control, and selecting the last path. Then we find this squiggly button thing that will convert the draft to a sketch. We then delete all the path stuff, and the sketch will be all that remains. Nice. Change the workbench to Part and select Extrude a selected sketch. It will ask us how much we want to extrude. Bahtinov masks don't have to be too thick. I'm going to go with 2.5 millimeters, but you could go with 2 millimeters if you want. I also want to create a couple of nubs that will help me grab the mask out of the dew shield. So go back to draft and find this circle thing. Click where you want the middle of the circle to be, and then move your mouse to where you want the edge to be. Once you've done that, click again and create it. It might be easier to rotate the model to the bottom, so use this cube up there if that helps. Now we can change our workbench back to part and extrude it. I want my nub to be about 5 millimeters taller than the Bahtinov mask. Because the mask is already 2.5 millimeters, I'll make the nub extrude 7 millimeters, but you can extrude it more if you'd like. I'm going to go ahead and put a second nub on here, but you don't have to, but it's nice to have. In this space over here is where you can control exactly how big the diameter of the circle is and where it's placed. Once you're happy with the nubs, let's export it. Control-click the 3 extrusions and export it as an STL file. Now in Cura or whatever 3D printing software you have, you can open it. Click on the model and you can check the dimensions on the scale tab here. Mine is 110 millimeters in diameter, which is perfect for my 80 millimeter refractor. But you can change the scale. Let's say you want it to be 200 millimeters in diameter. It doesn't have to be any thicker, so uncheck uniform scaling and change the X and Y dimensions to 200 millimeters. There you go. Nice. Now this is too big for me, so I'll take it back to 110 millimeters. I'll then slice it and print it. This isn't a tutorial on how to do 3D printing, but if you'd like me to do a tutorial on how I print my stuff for astrophotography, let me know in the comments. So let's print it. Alright, here it is. I hope you liked it. Please subscribe if you haven't already, and thanks for watching.